I just want to finish up what I didn't get to finish in class and talk about the cosine wave. What we're gonna build the graph of the cosine and let you see some of the patterns that arise with cosine. It's very similar to sine. You're just gonna notice a slight shift. So that's one of the patterns that we should notice, is that cosine is just a shift of the sine wave. So let's start with the cosine of 0. So obviously we can't use our triangles here. So what can we use? Well, we can use the circle. So the cosine of 0 is going to be the x value at 0 degrees or 0 radians. So the ratio is 1, or the x value is 1, so the ratio is 1, I should say. And then let's go from there. So the cosine of pi over 6. Pi over 6 is here. It's the adjacent side over the hypotenuse, so adjacent over hypotenuse. So it's square root 3 over 2. Then let's go to pi over 4, or 45 degrees. Cosine of pi over 4, adjacent over hypotenuse, which is just square root 2 over 2. And then we come to the cosine of 60 degrees, which is here. So it's adjacent over hypotenuse, so that's 1/2. And then we have the cosine of 90 degrees, which is just the x coordinate at 90 degrees on the unit circle. So that's 0. So there's our first quadrant. And if you remember in class, I introduced the hand trick once we got the first quadrant. All right, so I'll do it again. So I'm not going to redraw the hand. You guys have the picture of that hand. So I'm kind of shortening it here. The sine theta, remember, is the square root of the fingers below the folded finger divided by 2. Cosine is just the square root of the fingers above divided by 2. Okay, so let's see if that works. So the cosine of 0, you fold in your 0. Sorry, my hand looks a little funny when I fold in pinky. The fingers above, there's 4 fingers above. Divided by 2, the square root of 4 is 2, and 2 divided by 2 is 1. Okay, next finger, your 30-degree finger. So the cosine of pi over 6 is equal to the square root of the fingers above divided by 2, and it's square root 3 over 2. That's what we got here. These came from the triangles, so this little trick is founded in the triangles in this unit circle. Okay, next one, cosine of pi over 4. Cosine of pi over 4 is square root of the fingers above, which is 2, over 2. That matches. And then cosine of pi over 3 is square root of 1. There's 1 finger above, divided by 2, which is 1/2. And then I'll just say this one. The cosine of 90 degrees, or pi over 2, is there's no finger above, so the square root of 0 divided by 2, which is 0. That's what we got there. So now that we got that, we got the hand trick, we can complete the rest of the table without these triangles or circles. So let's try it. Okay, we know after 90 degrees, we're now in the second quadrant. And if you remember, all students take calculus. In the second quadrant, only sine is positive. So cosine is negative. So all these ratios should be negative. I'm going to hold off on the 180. We'll talk about that one. Okay, so 2 pi over 3, the reference is pi over 3. So it's square root 1 over 2, which is just 1/2. But it's negative because cosine is negative in the second quadrant. So a question might be, why is cosine negative in the second quadrant? Because if you remember, to find any point in a circle, the x coordinate is cosine of theta. This length is just cosine of theta. The y-coordinate is sine theta. And in the second quadrant, x values are negative, which correspond to how we find the x-coordinate. All right? So 3 pi over 4 is square root 2 over 2. Fingers above is 2, and it's always over 2. Then the last one, if 5 pi over 6, the reference is pi over 6. So the fingers above is 3, so it's square root 3 over 2. Then we come to pi. So pi is here on the unit circle, and the x-coordinate is -1. Okay, and then we continue around the circle. All right, so 7 pi over 6, we're in the third quadrant, still negative. Okay, 7 pi over 6 is pi over 6 reference angle, so that's square root 3 over 2. Reference angle's pi over 4 for 5 pi over 4, so that's square root 2 over 2. 4 pi over 3's reference is pi over 3, so this is square root 1 over 2, which is just 1/2. And then we're at 270. 270's here. On the unit circle, the x value is 0, so this is 0. Now we're in the fourth quadrant. Cosine is positive in the fourth quadrant. So we use the reference angle for 5 pi over 3 is pi over 3, so it's 1/2. Then we go down the line. Reference angle for 7 pi over 4 is pi over 4, so it's square root 2 over 2. 11 pi over 6, the reference is 1 pi over 6, so that's square root 3 over 2. And then we're back to 2 pi, which is equivalent to 0, back to 1. All right, so when I did the sine graph, I put each little tick mark for every angle that we use around the unit circle, but I'm just going to put what I call the critical values down here. So pi over 2, pi, 3 pi over 2, and 2 pi to see that curve. All right, so we look at where the graph starts. When your input or your x values, your angles are 0, the output is 1. So the sine wave starts at 0, 1. Then the next critical value at pi over 2, the y value is 0. And then at pi, it's -1. 3 pi over 2, 0. And then at 2 pi, it's back to 1. So I connect those dots with a curve. And there's the sine wave, a cosine wave, excuse me, over one period, or one trip around the circle. All right, and again, just like we talked about with the sine wave, this graph continues forever this way, and does the same pattern that way, and continues on forever and ever. Okay, so if I put my markers like I did in class with the sine wave, okay, we can see that in the first quadrant, the ratios are positive. After the first quadrant into the third quadrant, they're all negative. And then finally in the fourth quadrant, we're back to being positive. So there is the cosine wave. Hope this helps.